All right, you get $4 an hour for underwater paperclip folding, and you earn $7 per hour for feeding bananas into an automatic banana peeler. That is a real thing. You need to make at least $42 today, but you can work no more than 9 hours. We'll assume that's today. You're going to graph a system of inequalities that shows the possible combinations of hours that would work for this. Please pause the video and see if you can do this setup, and then come back and see what I came up with. Assuming you have paused the video, I have gone ahead and set up a table because tables help us organize our stuff. All right, so we're going to first look at the inequalities that are fairly obvious. There's a money issue, so there's something about $42. This is going to be the money inequality. And there's something about a number of hours. We can work no more than 9 hours. So this is going to be our hours inequality. And so there's something about 9 hours. Okay, so I'll start with sorting out what type of inequality this is. I can work no more than 9 hours, which means I could work 9 hours, but I could work less than 9 hours. So I'm going to have this be a less than or equal to inequality. So I go to my special characters, I type in less, and I get a variety of options there. So I've got less than 9 hours. I also need to make at least $42, which means I can make $42 or more. So this is a greater than or equal to inequality. And I get my greater than or equal to symbol. And there it is. Okay, now let's see what goes into these inequalities. All right. So we've been given some information about how much we make per hour, how much we make for underwater paperclip folding, and how much we make for feeding bananas into the automatic banana peeler. But we haven't been given any information about how many hours we're going to work at each thing. So it seems like our hours are our variable. So I'm going to use X for the underwater paperclip folding work hours, and Y for the banana peeler hours. So I've got an inequality now of X plus Y is less than or equal to 9 hours. Okay, since I've got hours going on here, I know I can't have negative hours, so X has to be greater than or equal to 0, and Y has to be greater than or equal to 0 as well. So now I have 3 inequalities, and we'll graph them and see where they all overlap. All right, now we've got to deal with the money piece. So we make $4 per hour for X hours. So 4X is the amount of money we make for underwater paperclip folding. We also make $7 per hour with the automatic banana peeler. So 7 times Y hours will equal the money we make there. So now I have this inequality. I've got the sum of 4X plus 7Y is greater than or equal to $42. I have all of my inequalities. There are no other inequalities to consider in this. I've got my explicit ones here and my implicit ones here, the implied ones. So let's go into Desmos and see how we graph all of these. So we're going to go to number 4 here. These are my inequalities. Now these two, we've graphed these before. X is greater than or equal to 0. That's just everything to the right of the y-axis and the y-axis. Y is greater than or equal to 0. That's everything above the x-axis and the x-axis. I have my initial overlap zone. That's the solution of that system. But I've got to deal with the rest of it. So we'll start off with this inequality, which is fairly simple. We're going to have an x-intercept at 9, 0, because if y is 0, then x has to be 9. And I'll have a y-intercept at 0, 9, because if x is 0, y has to be 9. And they are solid dots, solid points, because this is an or equal to inequality. So I'll go ahead and graph it. X plus y equals 9 is my line that I'm dealing with. And then now we care about which side is going to be shaded. So our test point, our usual test point is 0, 0. I plug that into our inequality. 0 plus 0 is less than 9. So 0, 0 got invited to the party. We'll shade this side of the line, which is solid because it's more equal to. Then I have this triangle area that is a solution to 3 parts of my 4 inequality system. Oh, now we're going to deal with this last inequality, and I'm going to plot the intercepts. So I've got an x-intercept where y is 0. So 4x equals 42. That means that I've got 42 divided by 4, which, okay, that's going to be 10.5, 0. And then I've got a y-intercept where I'm going to have, when x is 0, what is y? So I end up with 7y equals 42. I divide both sides by 7. I get 6. So 0, 6. And I'll go ahead and show the labels. These are solid dots because it's an or equal to. And I'll plot the line, which will be a solid line, where x plus 7y equals 42. I have my boundary line now. And now we need to figure out which side is going to be shaded. So we're going to test 0, 0 again. 4 times 0 plus 7 times 0 is 0. Is 0 greater than 42? It is not. So we're going to be shading that side. And so we will have this little triangle zone being our solution for our system of inequalities. It includes its boundary lines because they are inclusive. This point, and this point are all included as well. And I will now go ahead and go through the process of organizing all of this into a system that you can see just the solution zone as I work my Desmos magic. So I'm going to take one of the inequalities, make it a restriction for another one. I'll take another inequality and make it a restriction for that one. And now I've put all those restrictions. I'll turn these off so they're not distracting. And this is my solution zone. This is the possible combinations of X and Y hours. So I have this sort of domain of X hours that I could work on the underwater paperclip folding. And depending on what X is, I have these ranges of possible hours that I could work on the automatic banana peeler. And that's the answer.